Yeah.
Yeah, so let's take k equal to 1. K equals 0, we just get negative values, right? K equals 1, are we going to get a positive value? Well, pi is 3.14, and that's bigger than negative 2.5. I mean, that will make negative 2.5 positive. So we'll get this number, which is bigger than 0 and less than 2 pi, right? How about this one? Will this one also be positive? So this is a pretty small number here, right?
Yeah.
The angle whose sine is 0.1802 is probably pretty close to 0.1802. Is that a well-known thing? If theta is small, then sine theta is approximately equal to theta. Very useful approximation for small angles. Because it's a lot easier to compute theta if you have theta than it is to compute sine theta. And if they're about the same, just use theta. Why is that? Well, look at the graph. So here's this graph of sine theta. Here's the graph of y equals x, right? Or sine x here. And look in here, they're pretty much the same thing, right? So for small x, x and sine x are about the same. So this is going to be about, I mean, should we do it on the calculator? So I'm going to say, what is the sine of 0.1802? No, it's 0.179, right? That's pretty close, just a little bit less. So, with that in mind, I can see that this is going to be pretty close to negative 3. So, if k equals 1, I've got 3/2 pi. That's going to be bigger than pi, which is going to be bigger than 3. So that's a good value then, right? So this is also positive. Do I have more? How about if k equals 2? Am I still in the zone? Sure. So k equals 2, I'm going to have, what are we solving for? X? X could be negative 5/2 plus 1/2 the angle whose sine is, no, 0.1802 plus 2 pi? Is that? I think that's less than 2 pi, right? Because this is going to be about equal to negative 2, right? So this is good. How about the other one? I think that's also good, right? So when k equals 2 here, I've got 5 pi over 2. Is that less than, this is going to be bigger than 2 pi, but when I subtract 3 from it, approximately 3, right? I'm going to get something less than 2 pi. Sure. Are those all the solutions, or are there more? How about k equals 3? Well, with k equals 3, it's the same thing plus 3 pi. 3 pi is, getting close to 10. You got negative 3 plus 10. That's going to be too big. Big. It's a close call, huh? How about here? I'd have 7 pi over 2. Yeah, that's gonna also be too big. So I've got 3 numbers. Sorry, four solutions, and that kind of makes sense, right? When you've got a coefficient 2 here, that means instead of having 2 solutions, you have 4, right? In the interval from 0 to 2 pi. If you have a 3 coefficient there, instead of having 2 solutions, you have 6, right? Okay, so let's go ahead with, we want to compute this, huh? So, negative 2.5 plus 0.5 times that. How are we doing? And then plus pi, huh? It gets me this number, which is, I'm going to say a good number. Oop. All right. So if I copy that, paste it in here, there's one. 4 decimal places, okay, so we should be good with just the 4 decimal places here, right? What's the next one? Yeah, well, we gotta do some more work, right? So I'm gonna say, can I go back and get, no? Oh, geez. It's not a very friendly thing, is it? So yeah, we gotta say the next one is negative 2.5 minus 0.5. Arc sine, did I say arc sine before? I think I said sine. Oh, that was wrong then, right? So let's fix it, darn it. 0.5 arc sine of 0.1802.
Wait, no, we put 3.
Typo. Thank you. And then I'm going to add pi to that. Sorry, I have to say enter. Didn't like it. Did not match any documents.
When you say arc sine, is that how you say like inverse sine? Is that why you're doing arc sine?
Yeah, arc sine is the same as the angle whose sine is. Well, let's see, what do we got down here? Calculator? Oh. There is a calculator. Oh. I thought they disabled it in here. Okay, scientific calculator. Sure, let's go with that. It came back. Hooray. Okay, so where was I? 2.5 plus, it's negative 2.5, isn't it? Yeah, sorry. 2.5, change the sign. Add 0.5, get the inverse sign of, I want to be in radian mode. Crap. So I've got 2.5, change the sign, add 0.5 times the inverse sign of, oh, I see what it's doing. Crap. All right, so I've got to go back to the drawing board again. 2.5, make it negative. Add 0.5 times, and then I'm going to say 0.1802 inverse sine. Okay, can you see that it's correct, that's the right? On the top there it says negative 2.5. Looks like 25, there's a decimal there. Plus 0.5 arc sine of 0.1802. Okay, then I just want to add pi to that, right? So I'm going to say plus pi equals. I think it was 25, wasn't
Okay,
it?
the top one is for the top one. So K is equal to 1. K times 5.
I'm just not having any luck with this at all.
The bottom part?
Okay, one
is
more
the
time
bottom
for the
part
old
of X.
times.
So 2 times 1 is 2, plus 1 is 3, which gives you 3 pi halves.
So 2.5. All right, there's
These two
that
go
point.
together.
Okay, so
And
then
this one goes with this one.
plus
Oh, this one goes with this one.
0.5
This one.
times
Oh, okay, okay.
No, you're missing one.
0.1802. This is such an unforgiving calculator.
Oh, I'm missing one here. Huh?
Yep.
inverse sign.
Yeah, missing half of
Okay,
yeah.
plus pi
Close to-
equals, okay, now I'm getting a number, right? And, notice it's very close to the number I had before. Because the sine and the arc sine are pretty much the same thing here. Okay, where are we? Okay, so I had point. So yeah, I need to round up now, right? So I think I would have been off in the thousandths place or the 10,000th place.
73.22.
Yeah, 2-2, huh? Jeez, this is arduous. Okay. Comma? All right, so let's do the next one. So we'll go back to our calculator and we say 2.5 negative. Now we've got minus 0.5, right? Times 0.1802 inverse sine. Okay, and